Viewers, hope you will be fine. Today, in this exercise, we will perform radiometric correction and flash atmospheric correction, and we'll do land use land cover mapping using the Landsat imagery. So the first step is to open your NV software. You will go to File, then click on Open As, and select your specified data format like Landsat or any other format, and then you will click on GeoTIFF with metadata. Also, I have attached a screenshot of this uh, tutorial as well. And our second step will be to select metadata file of Landsat, and then we will load that file to NV software. And in step 3, from the toolbox, we will select radiometric correction. And from radiometric correction, we will choose radiometric calibration to calibrate the imagery and to apply different kind of flash atmospheric corrections on that imagery. Basically, radiometric calibration works to convert band sequential into band interleaved by line, or you can say it converts reflectance value in multispectral bands. I have mentioned the detail in this as well regarding it have different values for different kind of sensors as well. As you can see on your screen, there is ALOS, AV, near infrared to Prism level 1, ALSAT 2A, DMC data, EO Hyperion data, and the Goffin series data, GeoEye, Econos, and Landsat. As using we are using Landsat 8 data in our exercise, which have the capability to convert its value into radians. We can convert its values into reflectance and thermal bandwidth, and it also have a metadata of text file, which we can use in multiple softwares like NV. So these are some um, different kind of satellites which we can use in NV software for radiometric calibration. So going towards our first step to radiometrically calibrate, we will write here radiometric correction, or you can go directly from the catalog window. You can click on radiometric correction and then choose radiometric calibration. So by double clicking on this, this window will be open in front of you, and you will choose your bands as we are working on Landsat 8. It have multispectral bands, shorter infrared band, long infrared band as well. You can apply radiometric calibration on all these bands as per your requirement or as per specification of your project. I just chose multispectral band for radiometric calibration, and this window, after opening the radiometric calibration, will appear in front of you, in which a calibration type is mentioned, output interleave is mentioned, output data type. You can select as per your requirement. This can be double, float, or integer. And here is the output file name. After clicking on apply flash settings, save your output in the desired folder, and then you will click on OK button. This will change basically output interleave, which was band sequential during the acquisition of imagery, and now it's showing band interleave by line. As we are converting this multispectral into radiance, you can also calculate radiance reflectance values differences by calculating stats by right clicking on your multispectral imagery. So when you will right click on the imagery, it will show the quick stats. You can calculate its quick stats. You can change the color tables as well and the band animations. You can select as per your requirement. If you, for example, if you want to visualize the water features, then you will select green band of Landsat and infrared band of Landsat. And if you want to identify the vegetation indexes, using the line set, then you will select new infrared and word band combination to visualize the agriculture land or forest land or dense vegetation. And here you can see multispectral bands, minimum, maximum value, and mean standard deviation on your screen. So after applying radiometric calibration, we will go to toolbox again and open radiometric correction. We'll go to atmospheric module and then we will click on flash atmospheric correction from the catalog window, as you can see on your screen as well. Flash atmospheric correction. Just we will give input radiance, which we have already performed as the radiometrically calibrated imagery. And this window of flash atmospheric correction will be appeared in front of us. We will add our input radiance and then we will save our output reflectance and output directory. And there are some other options, sensor type and latitudes, longitudes, sensor altitude, ground elevation, pixel size, and flight date and flight time basically. These are in Landsat 8 um, satellite metadata file. We will choose from there. Firstly, we will select our sensor type from here, as we know that it's Landsat 8 imagery. Or after selecting this, it will automatically show its altitude and latitude, longitude of our child, and its pixel size as spatial resolution and ground elevation will be chosen from your project area. Flight date and flight time is mentioned in metadata file. We will choose from there that when this scene has been captured or taken and what time um, for that imagery. We will also select atmospheric model as per our area. I will choose a tropical model as I'm working in tropical region, and aerosol model. If you are working in urban area, then you will choose your urban area, and if you're working in rural area, then you will choose your rural area. And one more thing is to apply or choose KT upper band selection from the window. Um, so in flash atmospheric correction, we will use a single scale factor for radiance file and then click OK for that. And we will save our output in this step and we will open our metadata. And this metadata you can see here on that when this imagery was taken 24/4/2019 and the time was 5:44 in seconds. You will add these times and dates to flash atmospheric correction window. Then you will choose your sensor from this window. First, you will go to multispectral, then you will choose Landsat 8 OLI and specify data from metadata file, flight date, and time, as I have mentioned earlier as well. And you can specify your ground elevation from Google Earth Pro. You can check your elevation from internet as so I have chosen 0.2 kilometers altitude of my ground elevation. And I will just uh, choose atmospheric model as tropical and then select aerosol model for my study area as I'm working in rural area. After that, we will go to a multispectral setting and set Kaufman channel aerosol retrieval window and select KT upper channel as the highest band and the KT lower channel as the lowest band. KT lower will be selected by default. If it's not showing, then specify the channel greater lower channel in your satellite imagery, then you can click on OK. And this step you can see on your screen as well. I have chosen KT upper channel as shortwave infrared, and KT lower channel was red, which have 0.6546 micrometer range. And we will click on apply for flash atmospheric corrections. And after that, we will go to classification window in catalog. You will choose your classification window. and gives atmospherically corrected imagery to the classified window in its output, as you can see this step on your screen. You can also mask your shapefile, then you will select go next. From here, you can choose your shapefile and choose a method for classification as you use training data. If you want to perform unsupervised classification, then there is no need to add training data sets. And if you are doing supervised classification, then you need to add your training samples, or you need to make your training sample. Training samples can be um, um, drawn on Google Earth Pro and on this satellite imagery using the NV software as well. You can add multiple layers like built up water, vegetation, and barren land on the basis of literature review of study area. You can mark approximately 12 to 15 shapes for each class in the imagery and save your classes file to the output data folder. Here I have marked, four different classes for my region of interest. First one is built up, second one is vegetation, and the third one is water, and fourth one is barren. You can save your classes from there, and you can click on next to go to the its next window. Then you will choose an algorithm which you want to perform. You can do maximum likelihood classification, you can do minimum distance, you can do spectral angle mapper, you can do manhole distance as well. And after choosing your specific algorithm, you will just click on next for refinement of your results. And refined results will be shown to you as, and then you will save your output in the desired folder. And the output will be in two formats like raster format and format. You can save in your specified folder. After saving, output classified imagery will be shown on your screen, as you can see this classified imagery, and these classes will be shown as unclassified area, which are where we didn't make any class, and will be shown as 0 or black. After this step, we will go to GIS software, and we will classify or convert vector imagery from the raster imagery. We can add our shapefile um, for a specific region or our study area in ArcGIS, or you can add your file from add data window, or you can add your file from our catalog as. After adding your file, you will go to geoprocessing window, and you will just click on clipping tool, and it gives your study area as a clip feature and the classified imagery as input feature. Then you will click OK. And this step you can see on your screen. We have mentioned our study area and input, and we have mentioned our clip feature as we imported from in the software in clip feature, and you will click OK to clip your specific folder. Then you can classify in your next step. Um, we have four different kind of classes. Those are barren land, built-up area, vegetation, and water. You can classify those classes, and after this step, you will prepare a map by adding its title, north, legend, rates, scale bar, scale text, coordinates, and you can also add your author name, and this map will be your final result. And I hope this exercise will be helpful for all of you. And thank you very much.